Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at using trigonometry to find sides. So we're going to start off with a right-angled triangle. And remember, if we have an angle, which I'll call here theta, we label the sides O opposite the side facing theta. Hypotenuse is always the longest side. It's always the one facing the right angle. And then the other side that's next to theta is called A for adjacent. So we looked at three ratios, sine, cos, and tan. So remember, for example, sine of theta, that is the ratio of the opposite to the hypotenuse, opposite over hypotenuse. We looked at similar triangles and we learned that if this angle here is fixed, so too is the ratio. So if you put on your calculator, for example, sine 30, you should get a half. So if you get something different, it might be in the wrong mode. You need your calculator to be in degrees mode. Sine 30 equals half. So that means if this angle here were 30 degrees, then the opposite side is half of the hypotenuse. So we could use this to find one of those sides, the opposite or the hypotenuse, if we knew the other. So for example, because sine 30 is a half, if this angle's 30, let's say the opposite was 5, then the hypotenuse would be 10. If the hypotenuse was 20, then the opposite would be half of that, which would be 10. So that's the idea of how we're going to use trigonometry to find sides. So let's look at these two triangles, and in each case we're going to find the value of x. So when you're finding an unknown side, you first need to decide which ratio am I going to use. So here, if we look at this 20-degree angle, we have the adjacent side and the hypotenuse. So remember the acronym we went through last time, SOHCAHTOA? So cos is the one you use if you have adjacent and hypotenuse. So cos adjacent hypotenuse, because adjacent is written first, it goes on top. So after we've decided which ratio, we're going to set up our equation. So we've got cos of angle equals adjacent goes on top, because it's first in SOHCAHTOA, over hypotenuse. So over here for this one, it's the same sort of idea. We first need to decide which ratio. So for this 70-degree angle, we have the opposite side and the adjacent. So we have tan of angle equals, now because opposite is written first, it goes on top of the fraction. So we get 90 over x. So now we just need to solve each of these two equations. There's a slight difference here. Here, x is on the top. Here it is on the bottom. So this is just saying x divided by 12 equals cos 20. Cos 20 is just a number. So the way we undo dividing by 12 is we times each side by 12. So I get x equals 12 times cos 20. So putting that on your calculator and making sure that it's in degrees mode, I'll give the answer to two decimal places. It's about 11.28. Now over here, x is on the bottom. So to solve this equation, what I can do is times each side by x. That'll get rid of the fraction. And then I've got x times something equals 90. Now, tan 7 is just a number. Has a lot of decimal points, but still a number. So the way we undo timesing by tan 70 is dividing by tan 70. So I get x equals 90 over tan 70. And the answer I get there is about 32.76 centimeters. So note, when x, the thing we wanted to find, was on the top, we multiply. When the thing we wanted to find was on the bottom of the fraction, we divided. So make sure you remember this rule here, because that's probably the most common mistake, that people multiply when they should divide, or vice versa. All right, let's now do a slightly harder question. So we will now use trigonometry to find this length here, x. So the problem is x is not in a right-angled triangle. It's actually in this weird-looking triangle here. We only know how to solve for unknown sides in right-angled triangles. All that SOHCAHTOA business, the process I went through on the previous slide, only works for right-angled triangles. So here we have two right-angled triangles. We have a big one and a small one. Now, if I can find this length here, which I will call y, well then x is just 20 minus y. So to find this distance here in this small right-angled triangle, I need another side. To find a side in a right-angled triangle using trigonometry, you already need to know one of the other sides. So what I'm going to do first is I'm going to calculate this side here. I'm going to call it z, the distance from here to here. So the way I calculate z is using the big right-angled triangle because I have this side here and an angle. Side and an angle is all I need to use trigonometry to find what z is. So here I have the adjacent side to the 34-degree angle, and z is the opposite side. So I have tan 34 equals opposite over adjacent. So the thing I want to find is on the top, so I multiply. Z will be 20 times tan 34. So I just put that on my calculator, making sure my calculator's in degrees mode. And so the answer I get is about 13.49. Now, because I'm going to use this in a calculator in a second, I'm just going to put a few more decimal places. So now I can use z in this triangle to find y. So once again, I have opposite and adjacent. This time I'm trying to find the adjacent. So I have tan, because it's opposite and adjacent. That's the TOA part of SOHCAHTOA. Tan of angle equals opposite over adjacent. But I just found that this was 13.49017. So I can solve this just like I've been solving all the others. Now, unlike this one where the thing we wanted to find was on top, now the thing we want to find is on the bottom, so we divide. So I can skip straight to that step. Y will be 13.49017 divided by tan 68. Dividing because it was on the bottom. So I can just move this and the fraction line over there. That's the quick way to do it. So putting that on my calculator, I get about 5.4504. So that's the distance from here to here. So x will just be 20 minus that. And that's about 15.5496. So that is the value of x. So we just needed to use trigonometry twice because x was not part of a right-angled triangle. And then we're done. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.